In this video, we'd learn the connection between limit and definite integral. Some some limits are difficult to deal with. This is why we need to change them to a definite integral and deal with that. So suppose that this is the graph of f from A to B. So we divide it into n equal subintervals, x1, x2, and the last one, which is xn. First thing, we need to find a formula regarding delta x. Obviously, delta x equals b minus a over n. Also, isn't it obvious that x2, for example, if you look at this like graph, so this is delta x, this is also delta x. So if you want to find x2, you can say x0 plus 2 delta x. Likewise, if you want to go to x3, you start from x0 and you go ahead as much as 3 delta x. If you look at this pattern, we can say in general xk equals x0 plus k delta x. And since delta x is b minus a over n and x0 is a, you can write it as b minus a times k over n. Also, we already know that according to Riemann integral, the limit of right Riemann, when n goes to infinity, it becomes the exact definite integral from a to b. So it means limit of Rnf as n goes to infinity becomes integral from a to b f of x d of x. The formula for right Riemann is b minus a over n sigma f of xk. We already established these formulas. K from 1 to n as n goes to infinity. Now, knowing that xk equals this one that I'm going to highlight here with yellow. So knowing that xk is that, formula can be changed to f of a plus b minus a k over n goes to infinity equals integral from a to b f of x d of x. This is the formula that we advise all AP students to memorize. Very important, this formula. So how does it work? Let's have some examples. You need to have this formula with you because in each question we need to apply this. So let's say limit of 2 over n sigma f of negative 3 plus 2kn k from 1 to n as n goes to infinity. So what is the answer to this? Let's compare this one with the original formula. Okay. First thing that we need to figure out is A. What is A? If you compare these two, it wouldn't be hard to realize that A equals -3. Therefore, A equals -3. Also, it is obvious that B minus A equals 2. And since A is -3, B should be -1 because you want B minus A to be 2. And also, this green part all together becomes X. Therefore, what we are looking for would be integral from -3 to -1 f of x d of x. Of course, in this example, you are not given the equation of f of x. In the next example, we'll go deeper into it. So let's say 2 over n goes to infinity, k equals 1 to n. So 1 plus 2k over n squared. So we want to know this limit. If you apply that formula, which integral represents this limit? So again, the key point is A, which is 1 here. So therefore, it turns to integral from 1. Also, we know that B minus A is 2. I made it green. So therefore, it's integral from 1 to 3. And then the entire thing here is x. Therefore, it's going to be x squared dx. So obviously you know that integral of x squared is 1/3 x cubed from 1 to 3. So 1/3. So 3 to the power of 3 minus 1 to the power of 3. 27 minus 1 is 26 over 3. Let's have another example. You are asked about this limit. The difference between this question and the questions that we have done so far is that there is no sigma here. So this is you who need to change this to sigma format. Therefore, we are going to change it this way: sigma 1 over n, limit 1 over n, sigma e to the power of k over n. N goes to infinity. Oh, I made a mistake here. It was the last term is n over n. Okay. So obviously a is 0, and this becomes integral from 0 to 1 e to the power of x dx. Integral of ex is itself And once you apply the limits of the integral, it's going to be e minus 1. So the last example of today would be this limit. Limit of 2 over n I'm going to change it to 3 over n. 3 over n, and here would be 1 plus 3 over n, square root of 1 plus 3 over n, plus 1 plus 3 times 2 over n, square root of 1 plus 3 times 2 over n, plus, and it goes until we get the last term, which is 1 plus 3n over n, square root of 1 plus 3n over n. Again, what you see here, there is no sigma notation. So first thing, we try to change this to sigma notation. So it's going to be limit 3 over n sigma 1 plus 3k over n, square root of 1 plus 3k over n, k equals 1 to n, as n goes to infinity. Again, it's not too hard to notice that a is 1, therefore it becomes integral from 1 to, also b minus a is 3, and once a is 1, b has to be 4, and your function obviously is x, square root of x dx. This can be written as x to the power of 3 over 2 dx. The answer would be 2/5 x to the power of 5 over 2, because you add 1, right? 1 to 4. So 4 to the power of 5 over 2 minus 1, because 1 to any exponent is 1. So I need to know what is the exact value of 4 to the power of 5 over 2. Therefore, I'm going to write 4 as 2 squared. And then 2 and 2 cancel each other out, and we're left with 2 to the power of 5, which is 32. So therefore, the answer would be 31 times 2, which is 62 over 5. So this is how we change the limit to integrals.